Hello friends, today we are going to learn your chapter number 4, that is measures of dispersion. In this chapter we will learn what is dispersion, what do you mean by that, and how many measures are there of the dispersion. Here we have already solved the quartile, Q1, Q2, these all things we have already solved. Based on that only another type of sum is being asked. First of all, we will see some theory and then we will go for the sums. Let's have a look. First of all, what do you mean by dispersion? A measure which shows how far the observations of the data are scattered from the average. That means from the average, how far the data are scattered. That is known as dispersion. We have learned the measures of central tendency in the previous chapter. So based on that central observations, how far the other observations are dispersed, how far the other observations are scattered from that average, that is known as dispersion. So the measure of dispersion shows how far the data are dispersed from the average. From the average, how far the data are dispersed, that is known as dispersion. There are basically two types of dispersion. First is absolute measure and second is relative measure. Basically there are two measures of dispersion, absolute measure and relative measure. Now what do you mean by absolute measure? When the dispersion is expressed in the same statistical unit. That means if it is kilogram, then dispersion is to be expressed in kg only. If it is milliliter or liter, then dispersion should be in the same unit. So the measure of dispersion which is expressed in the same unit in which the observation of the data are expressed is called absolute measure. Okay, so if here one example is also written, if in the original data kg is given, then absolute measure will be in kg. Next is a relative measure. This measure is generally free from the unit of measurement. That means here no unit of measurement is to be written. If in question, if in sum kg is written, so in absolute measure we will write kg, but in relative measure we will not write kg. We will not write any unit in relative measure. So the relative measure is generally free from the unit of measurement. Okay, absolute measure and relative measure. Next is, there are how many measures of dispersion? Generally it is asked in one-liner also. There are total how many measures of dispersion? So there are total 4 measures of dispersion. The very first is range. Second is quartile deviation. Third is mean deviation. And fourth is standard deviation. So there are total 4 measures of dispersion. We will study these 4 measures of dispersion in this chapter. We will study these 4 measures of dispersion's absolute measure as well as relative measure. That means for range we will study first absolute measure and then relative measure, then for quartile deviation same, then mean deviation, and the last will be the standard deviation. In this way, in this chapter we will study the 4 measures of dispersion. Let us study the first measure of dispersion, that is range. What is range? Range is the difference between the highest value and the lowest observation. The highest and the lowest observation of the data is called range. As we can see here, it is denoted by R. You can see the formula also. Range equals to XH minus XL. What is XH? XH is the highest observation. And what is XL? XL is the lowest observation. So from the highest observation we have to minus the lowest observation, that is range. Okay, and if you want to find here, this formula is the absolute measure. Absolute. Okay, this formula is the absolute measure. Next is relative measure. Here you can see it is written absolute measure of dispersion having the same unit of the observation. Now next is relative. If we divide the range, if we divide this R with XH plus XL, we will find the relative range. So that means R upon XH plus XL. So what is the formula of R? R equals to XH minus XL upon XH plus XL. So what is the formula of relative range? XH minus XL upon XH plus XL. And relative range is also known as coefficient of range. Here you can see coefficient of range. Relative range is also known as coefficient of range, and it is generally free from the unit of measurement. Here you don't have to write kg, milliliter, liter, gram or anything else. So range, what is the formula of range? Range is equal to XH minus XL. And what is the formula of relative range? XH minus XL upon XH plus XL. What is XH? XH is the highest observation. And what is XL? XL is the lowest observation. Now we can see one sum based on this formula. Here values is given. The runs scored by the batsman in the last 10 innings of a cricket match is given. We have to find the range. First of all, we have to see which is the highest observation. From this observation, the highest observation is 93. You can see here the highest observation is 93. And what is the lowest observation? In this observation, what is the lowest observation? The lowest observation is 18. You can see the lowest observation is 18. Now we have to find the range. Range is equal to XH minus XL. So 93 minus 18, which is equal to 75. So here we have written 93 minus 18 equals to 75. So your range equals to 75 runs. Here we will write the unit. Whereas now find the range as well as the coefficient of range. Coefficient of range means we have to find the relative range. So what is the formula? R upon coefficient of range is equal to R upon XH plus XL. R we have already found 75 upon 93 plus 18, that is 111. So 75 divided by 111 is 0.6757. So what is the value of coefficient of range? We have to round it off. So your answer is 0.68. Here you don't have to write the unit. Okay, 0.6. Here in this sum you can see that what is the highest value of observation. We can see here the highest observation is 12,000. See. Now what is the lowest observation? The lowest observation is 3,500. So what will be my range? Highest observation minus lowest observation. So 12,000 minus 3,500, that is 8,500. Now we will find the relative range. Relative range, that is coefficient of range, equals to R upon XH plus XL. So 8,500 upon 12,000 plus 3500, that is 15,500. Here we have written like this, 8,500 upon 15,500. So if we divide this, we will get the answer 0.55. So the range of the monthly salary of the worker is 0.55. Next measure of dispersion is quartile deviation. We have already seen that there are 4 measures of dispersion. In that, the very first was range, that we have already discussed. Now the second measure of dispersion is quartile deviation. We will discuss this formula of quartile deviation. In that we will have to learn the formula of absolute measure as well as relative measure. So absolute quartile deviation, that is QD, and relative quartile deviation. Again, absolute quartile deviation will have the unit, but relative quartile deviation will not have the unit because it is free from the unit of measurement. So how we will find the quartile deviation? What is the formula? Formula is QD equals to Q3 minus Q1 upon 2. You can see the formula, QD equals to Q3 minus Q1 upon 2. That means difference between third and the first quartile. Two extreme quartiles, third and first. So it is also, this quartile division is also known as semi-interquartile range. The another name of quartile deviation. This can be asked in MCQs. Semi-interquartile range. And if we divide this QD by Q3 minus Q1, so we will get the relative range. So Q3 minus Q1 upon 2 upon Q3 plus Q1. Okay, upon 2 will get cancelled. We will get the formula Q3 minus Q1. In denominator it is plus, so Q3 plus Q1. Okay, Q3 minus Q1 upon Q3 plus Q1. The relative quartile deviation is also known as coefficient of quartile deviation. Coefficient of quartile deviation. And again, it is free from unit of measurement. So here we don't have to write any unit. Now we will see the sum based on quartile deviation. Here data is given, that is discrete data. We have to find the quartile deviation and the coefficient of quartile deviation. That means we have to find the absolute measure as well as the relative measure. Here xi and fi is given. First of all, we have to find the quartile division QD. What was the formula of QD? QD equals to Q3 minus Q1 upon 2. So we will have to find Q3 then Q1 or upon 2, or you can find Q1 then Q3, then we will divide it by 2. So here we have already found Q1. Here xi is given, you can see xi, then fi. Next step will be find CFI. How will you find CFI? CFI means we will have to add up the frequencies. Like first is 3, then 3 plus 12, that is 15. Okay, then 15 plus 18 is 33. 33 plus 12 is 45. 45 plus 5 is 50. So you have to add these all frequencies and we have to find the cumulative frequency, that is CFI. After that your n will be 50. You can see here n equals to 50. Okay, so what is the formula of Q1? Q1 first quartile, Q1 equals to n plus 1 upon fourth observation. Okay, Q1 and Q3, Q1 and then Q3 we will find. So Q1 is equal to here you can see Q1 equals to value of n plus 1 upon 4th observation. So n means 50, 50 plus 1 upon 4 is 12.75, but we will not find 12.75 exactly. So what we will consider the next higher value after 12.75, which is 15. Okay, so what will be your first quartile? Parallel to the 15, the xi which is given, that is 4. Okay, we will see the xi in front of the cumulative frequency. So what is xi? Xi is 4, so your q1 will be 4 minutes. Okay, next q3. Q3 means 3 into, here we have already found 3 into n plus 1 upon 4th observation, that is 38.25. So what is the next higher value after 38.25 is 45. So 45 is having what is the x in front of 45? That is 8. So here 8 is the q3. Now what is the formula? q3 minus q1 upon 2. So q3 is 8 minus q1 is 4 divided by 2. So that is 8 minus 4 is 4. 4 divided by 2 is 2. So here quartile deviation QD is 2. Now what is the coefficient of quartile deviation? Q3 minus Q1, you can see the formula upon Q3 plus Q1. Q3 minus Q1 we have already found, that is 8 minus 4. 8 minus 4 is 4. Upon Q3 plus Q1, 8, you can see 8 plus 4, that is 12. So 4 divided by 12 is 0.33. So your coefficient of quartile deviation will be 0.33. Here we are not supposed to write the unit, but here we have written the unit because this one is free from unit of measurement, and here you have to write the unit. So your coefficient of quartile deviation will be 0.33. In this way, we are going to learn the measures of dispersion, that is range and quartile deviation we have already learned. Now we will study another measures of dispersion in my next video, that is mean deviation and standard deviation. We will see the formula of mean deviation and then we will solve the sum of mean deviation. Again for the standard deviation we will follow the same procedure. So in this video you have learned the two measures of dispersion, that is range and quartile deviation. I hope you all have understood the formula as well as the sums of range and quartile deviation. Thank you.